Welcome to the Real Python Podcast. This is episode 52. Have you heard about NoSQL databases or wondered how to use one with Python? How does MongoDB store information? And what packages can you use to connect this type of database to your Python project? This week on the show, David Amos is back, and he's brought another batch of PyCoder's weekly articles and projects. David talks about a recent Real Python video course about managing namespaces in Python. We also take a look at a few recent stories about the Python packaging ecosystem. We cover several other articles and projects from the Python community, including generating customizable PDF reports with Python, how semantic versioning will not save you, PEP 621 is final, a user hits the Python community with 4,000 fake modules, making a synth with Python, and what is running on the Mars helicopter. This episode is brought to you by DigitalOcean's app platform. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, David, welcome back to the show.
Hey, Chris, thanks for having me back again.
All right. We got a whole bunch of interesting PyCoder stuff.
Yeah.
This kind of combines a few things that we've talked about in the past. I had Mike Driscoll on to talk about PDFs and Report Lab, and we've talked about Leodonis's entire massive PyQt learning path that dives super deep into it. But this article combines them together in a really kind of fun way, and in my opinion, makes a very useful tool.
Yeah.
That I've mentioned several times about talking with small businesses and creating tools for them. And this, in a small amount of code, you're making a customizable PDF report builder with Python and PyQt. And it uses all those things. It also uses something else we talked about before, which is PDFRW, which is a very nice tool in Python for working with PDFs. And it's by Martin Fitzpatrick from learnpyqt.com. Basically, you go through this process of starting out with a template PDF so that if you have, say a letterhead or a certain kind of look and feel for an existing form that you want to have generatively filled out, either by someone going in and filling out the form field by field via a PyQt layout, it can do that. Or you can have it generate it based upon a set of fields coming in from something like an Excel file or a CSV file. And they show you both. And it's pretty slick. And so it kind of goes through the whole process of building up not only where the forms will lay out inside there, the PyQt fields, how to kind of create this thing called a generator inside of that. And then it's really slick. I was impressed with the code, got it running on my machine pretty easily. And I could see customizing it pretty quickly into a solution for, again, some of these small businesses. That was a really common thing for me to do, is build fillable forms for them. And this would even take it to another level of having it run on here. I could see maybe even combining it with something like Beware. And I know that Russell had an announcement, and I guess Beware is working on M1 Max, which is cool too. So a new version of Beware out there.
Yeah.
So check it out. It's a neat little article kind of diving into customizing PDF reports and combines all these little technologies that we've talked about. Very readable, very easy to get up and running. And it seems like a neat site. Again, if you want to dive even deeper into learning PyQt, learnpyqt.com looks like it's got lots of other interesting resources for free to check out too.
Yeah. One cool thing about this article too is all of the code examples have little tabs at the top of them.
Yeah, for versions.
Yeah, to switch between the code using PyQt 5 or PySide 2 or PyQt 6 or PySide 6. So he's got the different implementations there for each one, which is pretty cool.
There's a fun little joke in the whole thing. I don't know if I should spoil it or not.
Yeah.
Of what you're creating. So hopefully you'll find that as a fun little surprise for those of us who've seen that movie. So we were going to dive into a pretty intense topic next that we're going to hit from multiple sides. And so I guess we'll have you start with your first article.
Yeah, it's kind of, we got a little packaging theme going on.
Yeah.
And the first article that I've got is by Heineck Schlawak, and it's called Semantic Versioning Will Not Save You. And this first popped onto my radar. Well, not this particular article, but there was a lot of chatter on the Twitter about a pretty emotional GitHub thread. That's actually Heineck's words that he uses in his article, and it's very accurate. There was a lot of high emotions involved, but the Python package cryptography changed their build system to use Rust for low-level code.
Yeah.
And this was a pretty big change in the build system. It's important though to remember this is the build system. This is not affect, like when you pip install cryptography, you're installing from a wheel that's already been built. And so there's no like Rust dependency for using cryptography or anything like that. But this change in the build system caused quite a stir. And the way that Heineck describes this, he says, enthusiasts of 32-bit hardware from the 1990s aside, there was a vocal faction that stipulated adherence to semantic versioning from the maintainers, claiming it would have prevented all of the grief. And there was a lot of pushback to that. There was also a lot of people saying, yeah, they broke semantic versioning. And this article does, it kind of doesn't take a side on whether or not semantic versioning was actually broken, although it kind of does in a footnote. But the point of the article was not whether or not this actually broke semantic versioning. The point was that even if it had broken or had not broken, this reliance on semantic versioning to sort of save you from any breaking changes is not necessarily a good mindset to have. And so kind of if you're not familiar with, I guess for listeners that aren't familiar with semantic versioning.
Yeah, so I was thinking is maybe we could take a step back and kind of explain what that means, because I feel like there's a lot of this sort of stuff in the packaging world that we've tried to decode a little bit and sort of explain, and semantic versioning is one of those that it's a lot of big words. You're like, okay, well, what does that mean? And what are the rules?
Right. Yeah. So it's pretty common. It might be the most widely used way of expressing versions of packages. I don't know that for a fact, but it just seems like you see it all over the place.
Yeah.
What it is you have a version number, say something like 1.10.0, right? So the first number in that triple is the major version. So version 1. The second number is the minor version. So that would be minor version 10. And the last number is called the patch version or the micro version. And so in this case, it would be 0, right? 1.10.0. And the idea, so semantic version is supposed to come with like, okay, not only do I have this version number that describes, that sort of breaks it down into like this major, minor, and patch version, but there's also supposed to be kind of this promise that as long as the major version doesn't change, I'm guaranteeing no backwards incompatibility or no breaking changes. So that if you had version 1.9.0 installed and you upgraded to 1.10, in theory, it should just work. It wouldn't cause any issues.
Right.
So, I mean, this is all theoretical though. I mean, there's nothing about semantic versioning that actually guarantees this. It's up to the maintainers of packages.
You can use it however you want, right?
You can use it however you want. Yeah, exactly. But
right. It kind of goes back to that zero-ver thing I've heard people say too. It's like, there's these people that hung on to like 0.75.1, or whatever, where like the zero-ver goes on forever.
Right. Yeah.
But you're right. Those aren't rules. These are just guidelines.
It's an idea. It's a guideline. It's sort of like how it's quote unquote supposed to work. But yeah, and the whole zero-ver thing is like your major version is 0. So it's sort of like this offshoot of semantic versioning where you keep your major version at 0. And the idea is that until you get your major version to 1, it's kind of anything goes. Like the API could totally change.
It's beta.
Exactly. Yeah. It's like it's a beta type thing. So So that's what semantic versioning is. And he talks about in the article this Hiram's law, which basically states with a sufficient number of users of an API, it does not matter what you promise in the contract. All observable behaviors of your system will be depended on by somebody. So even if you have, say, a bug, and someone is utilizing this bug in some way that they're relying on it, then when that bug gets fixed, for them, that's a breaking change.
Right.
Basically, it's impossible to predict how a change is going to affect all of your users if you have a wide enough user base.
Yeah.
And the point of this article is just that, the responsibility for packages falls on both ends. There's the package maintainers that have a contract and are supposed to follow that. But as a user of a package, it's your responsibility to not assume that just because there wasn't a bump in the major version, that everything is going to work fine. You need to test it. You need to take some responsibility yourself,
right,
and not just blindly expect that this contract wasn't broken. And if it was, to alert the maintainers in a constructive manner and be a good citizen and help them with that. So he lists some things that I want to just kind of rattle them off for a second, because I think it's, if for listeners that don't read the article, it's important stuff to keep in mind. And one is have tests with good coverage. Pin your dependencies to exact versions and regularly try to update your dependencies to their latest versions. And if your test passed, then you can pin to the new versions. So this is kind of a framework for when a new version is released, how you can go about upgrading. The wrong way to do it is to say, oh, they released a new version, so I'm going to go into my requirements file and pin it at the new version and then push it out, and everything's going to be okay.
Yeah.
And nothing bad's going to happen.
Well, I think about the pinning technique of using like the greater than kind of thing potentially could be problematic there too.
It could, yeah.
You got to think about how you're going to pin like from here down, or probably preferably equals, this is the version that we've tested on and it works on. So
right. Yeah. There's kind of this mindset I've heard where, if you're writing a library, you should pin your dependencies. If you're writing an application, you can kind of fudge it a little bit and use the greater than and less than, or those kinds of version specifiers. I tend to just pin everything just because I know, hey, I've got it working.
Yeah.
And upgrading a dependency can be a hassle, because especially if that dependency has several other dependencies.
Right.
But if you pin it, then it's going to work when it gets distributed, whether it's an application or a library. So take that how you will if you're listening in. But anyways, it's just I thought it was a really good article with really good advice on how you should approach upgrading your dependencies and where responsibility falls with all this. So, and I'll just read what he has at the end here of the article. He just says, so please use version numbers only for ordering releases. Take responsibility for your builds, and don't harass maintainers to provide you with even more free labor that has only marginal upsides for you at best. So basically, be a good citizen.
Yeah, totally. Yeah, especially if you're depending on it. Yeah, and the systems that I think that we're having a problem were, like you said, like really,
they're pretty archaic.
Or it was at least commented on the Twitter thread. Yeah, I mean they're specific old hardware. I had my own breaking change with hardware this week of upgrading to a Mac M1 processor, and my expectation that a 20-year-old MIDI interface that has a USB port on it, why shouldn't it work? That's kind of a little steep for even me to get upset about it. But I see people get upset online. I've read those forum posts myself. So it's one of these things, and I can understand there's limits to the hardware and software, and also open source. There's going to be limits. So
yeah.
But yeah, it's, especially if you're approaching it with good faith, you would hope. This episode is brought to you by DigitalOcean's App Platform. DigitalOcean's App Platform is a new platform-as-a-service solution to build modern cloud-native apps. With App Platform, you can build, deploy, and scale apps and static websites quickly and easily. Simply point your GitHub repository and let App Platform do all the heavy lifting related to infrastructure. Get started on DigitalOcean's App Platform for free at do.co/realpython. That's do.co/realpython. Next one is about a new PEP that's been in the works for a little while. It's PEP 621, and it's sort of the announcement that PEP 621 is final. And it's a PEP from, well, Brett Cannon's one of the lead people on it. And he sort of spoke about this really briefly on our episode together. And I may have him come back and talk a little bit about it because he's really a champion on packaging, kind of going back down this packaging thing.
Yeah.
And the note is that in the near future, you'll be able to store project metadata in pyproject.toml files. And toml is another sort of markdown style file. It actually stands for Tom's Obvious Minimal Language, which is kind of a funny name. And I guess that's by Tom Preston Werner and Pradian Gedem. What might be good for people to do, and I'll include links for this, is there is a post from last March, almost a year ago, exactly, from Brett Cannon that's titled, "What the heck is pyproject.toml?"
Yeah.
And it goes back to PEP 518, and 518 and pyproject.toml changed. Now a tool like pip can read the pyproject.toml and see what build tools are specified in it and install those in a virtual environment to build your project. That means you can rely on specific versions of setup tools and wheel if you want. Heck, you can even build with a tool other than setup tools if you want. And then those are other tools that can rely on the same file called Flit or Poetry. You might have heard of these.
Yeah.
But since these are other tools require pyproject.tomls and their users are already familiar with that. The key point is that assumptions no longer need to be made about what is necessary to build your project, which frees up packaging ecosystems to experiment and grow. Okay, so the things that are in this pyproject.toml file can communicate with PyPI for uploading, and it sort of standardizes those names and the fields, things like the name of the project, and that's necessary for the file name, the version, going back to what we were talking about of like potentially how you want to do your versioning number, the description, which is sometimes described as a short description and then an actual readme, and then requires, which goes back to pinning and the idea of like what are the things that are needed to build this thing, the other dependencies that are in there, a license, the authors and maintainers. And that would include like not only the authors' names, but also their email addresses and ways to contact them, keywords and classifiers, and then URLs, which are a whole set of URLs that could be, where the docs are, where the project's hosted, and all that kind of stuff. So it's really just sort of standardizing a lot of that. A TOML file feels a lot almost like a JSON file, the way that it's sort of organized. It's very much in sort of a dictionary sort of style. It's something that's hard to describe over audio, but I'll include links not only to the post about PEP 621 being final, but again, the blog post from Brett Cannon. And then there's some other information I'll include there that is the discussion going kind of behind it, and then finally kind of coming to consensus. A lot of consensus lately, which is great. Great to hear.
Yeah.
Kind of early in the development of the next version of Python. And again, anything to make this stuff be more standardized, I think is great. Standardizing the tools. I think that's a bit of a complaint people have had about the Python ecosystem is sort of packaging in general. And we've been touching on it a lot, like what are wheels, what are SDIS, what are these other kinds of things. And this is one of these things that's going to help try to, narrow the landscape a little bit, make it a little more easier to understand and describe. Again, this is really tools for people that are maintaining packages and sort of describing the recipe that, not only created this thing, but also all the ways to rebuild it and can be read by these other tools to make it much simpler.
Yeah.
So then We got another packaging story.
Yeah, and speaking of packaging and I guess making it even easier to package, with more power comes more responsibility. And
exactly.
there was an example of misuse of, or some irresponsibility, I guess, recently with the Python package index. And this is, I guess it was a couple of weeks ago, but it just kind of came across my radar within the last week or so. And this was, there's been, I guess we should preface this by saying, and we've talked about this a little bit in previous episodes, where there's been these cases of malicious packages that are sort of mimicking commonly installed packages by leveraging like common misspellings. So like if you're trying to pip install requests and you swap the U and the E on accident, like if there's a package called requests with the like EU instead of UE, then you'd be installing that and you don't know what it does, and it might do something malicious.
Yeah, we talked about that file that potentially run code depending on how you're installing it. So
yeah. And just recently there was a PyPI user with the name Remind Supply Chain Risks, which is kind of an unusual name, and executed what is, I guess, kind of like a supply chain attack, which is, or was sort of bringing to light this thing. There's something called a supply chain attack. And this is where you have, say, a bunch of private packages that might share a name with a public package. And if you're not careful, when you're pip installing those, it might reach out and grab the public version and not the private version. So you're not installing the version, not the version, I should say. It could be a totally different package, but there might be like a public package with the same name. You might be installing something that you just don't even know anything about. You don't, and it just shares the name and nothing else. So this user uploaded somewhere around 4,000 fake packages basically to PyPI in a very short amount of time. And fortunately the PyPI team removed them very quickly. And I think at this point there's nothing on there, but there was this kind of attack. I think it's important to note too that this is not something that's like specific to Python, and it's really any language that has like this public package repository that you're installing from. I mean, JavaScript has something like this with like the npm, and is subject to similar kinds of attacks. It's it's something just that can happen, and people need to be aware of. And the thing that I like about this article is it gives 4 sort of actionable items at the end that people that are installing packages need to just be aware of. And the first one is kind of obvious, like you shouldn't have to say this, but I guess you do because of incidents like this. And that is, don't do mass bogus uploads like this just to like prove a point or something, which is kind of what this user was doing.
Yeah.
And don't choose a PyPI package just because the name looks right. Check that you're really downloading the right module from the right publisher. Even legitimate modules sometimes have names that clash, compete, or confuse. So before you download it, you can go to pypi.org, you can type in the name, and you can see where does that come from? Like, who is the publisher? And a lot of times there's even an email. I mean, you can kind of do a little bit of due diligence and just make sure that you're actually downloading the right package there.
All the things that we were just talking about are listed: the name, the version, the description.
Right. Yes.
All those things that come out of them.
Yeah, that metadata that they're moving over to, or they're putting up now. You'll be able to put in PyProject Helma. Yeah, that metadata is listed on pypi.org. You can even see it using pip. Like once you've downloaded it, you may not even have to download it, but you can use like a pip show to show to show metadata about a package. Another important point is don't hook internal projects to external repositories by mistake. So if you're using Python packages that you haven't published externally, then one thing you can be sure of is that all external copies of your package are imposter modules and might be malware. So don't accidentally hook your internal projects to external repositories, and don't blindly download package updates into your own development or build systems. And this kind of goes back to what we were talking about with Hynek's article about semantic versioning is just this blind reliance is what can get you in some sticky situations. And, I mean, if you're just doing a pet project on your computer, and especially if you're like, not even hooked up to the internet, which I guess you'd need to be to download something from PyPI. But it's not. I guess it's not as big of a deal unless there's something really malicious going on, and it's trying to find private information on your computer. This is really for people who are working with code that's going to be running in production, that's going to have lots of users, that's going to be relied on by other people, a company or something like that. But it's just good practices. This is all just really good practice. And it's just, again, it's not something that's specific to Python even. It really is just the state of modern software. These are just things that people need to be aware of and need to be thinking about and taking responsibility for. So lots of PSAs today.
Yeah, definitely. Yeah, it's us today. Diving into some real Python content here. I mentioned Leo Donis earlier. In Leodonis Pozo Ramos, he's updated an existing article that was fairly popular on Real Python about Python and MongoDB.
Mm-hmm.
And I know there's a lot of MongoDB fans out there. If you're not familiar with MongoDB, it's a NoSQL database. It basically doesn't require the same sort of schema and tables and stuff that is very, very structured with standard SQL style databases. It uses going back to talking about dictionaries and JSON format. It uses a very JSON like style format as far as like how things are sort of organized and how you insert things into the database and how you pull them out. And this article dives into basically setting up Python to interact with it. And so I followed along. That's a very common thing for me to do, is to make sure that I am comfortable going through and repeating all the steps that are in it before I go and start talking about it on the show. And so I saw very quickly that you'd have to install MongoDB on your computer. And I was hesitant to do that because I usually use virtual environments for these kinds of tests, because I do all sorts of different ones in reviewing video courses and doing this show and things like that. And it's nice to be able to, not necessarily have a very messy, internal environment for all these kinds of things.
Yeah.
And so instead of installing it all from scratch, I said, well, it looks like I could probably do this via Docker and use a Docker container. And the instructions don't go real deep into using Docker specifically. So I'm going to include a link that might help some people with it, because I ran into some trouble. I was able to do all the standard stuff with it and was able to, break into like a shell and talk to the database. And it looked like I was making a client connection, because, usually if you're doing this sort of internal development, you use like a local host and then a port number. And all that seemed to be working fine. But then whenever we tried to insert stuff, it would just say no connection. And so anyway, I learned a better way for me to set it up, which is, kind of knowing more about the commands of using Docker and specifically setting up the port for MongoDB.
Yeah.
So regardless, a little bit of a technical stuff to get into. This article shows off two technologies, two packages that help with this. One's called PyMongo and the other one's Mongo Engine. And then it has references for deeper stuff that kind of get into almost ORM, object relation, model sort of stuff with Mongo. If you would need more of that, want to be able to kind of talk objects back and forth between Python and that. But it's really well done. It's really updating it to make it work and a little bit more modern. A lot of these packages have changed a lot in 4 or 5 years. And so Leodonis did a good job getting all that going. I think it's a nice introduction if you haven't played with NoSQL databases or Mongo specifically. It gets you going on it. After a little bit of a headache of trying to get connections going, I was able to go through it and get it working pretty well for myself. Mostly you're doing stuff kind of in a REPL, but again, this other article I'll include, it has a link, kind of even shows you a couple of scripts that you could use. Again, just sort of sending and receiving data and getting it talking. It's a nice introduction to the topic and nice way to kind of show you some of the packages that you could use to get Python talking to it.
Yeah, MongoDB is pretty cool. I haven't used it a lot. In fact, I've never used it in like production or anything like that. It's always just been to play around with. But I know that I know, for example, Mike Kennedy really, really likes it. I think.
Yeah, he's a huge user. Yeah.
Yeah, I think he uses it on pretty much everything. And the format's nice. And yeah, I mean, it's kind of convenient. Like you said, it's got the JSON style kind of formatting for documents and things like that.
Yeah, it's really super document based, so that the types of things you can store in it feel more like a big bag of differently shaped things, as opposed to the structure that is required of the other types of databases that we've talked about mostly, where you literally, I need fields for everything, if not it's going to be null here or whatever. It's very, very different.
Yes, it is. Yeah, it's a different kind of mindset. And I know, like, for me, having come from the relational databases and everything, at first it was kind of confusing. Like, it really took a while to kind of click, like, how it really worked and like what I could do with it and why it might be better in some cases than what I was using before. So yeah, it's definitely different.
Yeah. Cool. But it's definitely being used more and more.
Yeah.
Just the types of data that are out there, and definitely with social media and big data, that's where I started to see more and more and more, not only places using it, but articles and resources kind of pointing to this. Maybe we need something beyond a structured relational database. So cool. You got another Real Python recent posting here?
I do, yeah. And it's a course, actually a video course, not an article. It's from Johan Vergeer. Hopefully I'm pronouncing that correctly, but it's called Navigating Namespaces and Scope in Python. And I was excited to see this come out because I think that this is a topic that, well, it can be confusing in any programming language. I think it's particularly confusing in Python because the rules seem very different from a lot of other programming languages. And so yeah, it was just nice to see this, see this coming out, and so that people can learn how this works. It's such an important part of programming. I mean, that's even there's a whole line in the Zen of Python about namespaces are great. We should do more of those.
Yeah.
And it is. I mean, it's a great tool, but you need to understand scope when you get into this and how that works. And the course walks you through, how Python organizes symbolic names and objects into namespaces, when a new namespace is created, and how you can implement namespaces. It also dives into variable scope, how Python determines when names are visible. So this is like, for example, if you have a variable called X defined kind of at the root of your Python file, then if you declare another variable called X like inside of a function, this is like how it knows that X is not the same as the other variable X and things like that. So scope is really an important topic, but I think it kind of gets overlooked by beginners, and there's some confusing things that can happen if you don't understand how scope works, that for a beginner can just be like, the bash your head against your desk repeatedly for an hour trying to figure out like why isn't this working, like what's going on. And then it also introduces the LEGB rule, which is kind of it's a mnemonic for remembering how Python scope rules work. And it stands for local, enclosing, global, and built-in. I won't talk about all the details of what all those words actually mean, but that is a rule that you can use to kind of know where you are in the scope, in the land of scope in Python. So yeah, it's a really great course. It's not a super long course.
Yeah.
So you can get through it pretty quickly, but it covers a lot of really important topics. And yeah, I think the whole thing is it's 27 minutes. If you get an extra half hour, then and you don't know much about scope, or it's a sticking point for you, this is a great video course to check out. Highly recommend it.
Johan's one of our new instructors, and I was helping him get it going, and he was going through the LEGB rule, and he had this example at the end where he sort of removed all references, like definitions of this thing. And so you can actually see in an error statement, kind of going from bottom up, it looking through all of those. And so I said, man, we should focus on this because I think it's really good to see it looking in the local space, then looking in the enclosing space, then looking in the global space and not finding it, and then the error printing it out and kind of explaining it. So that was a really fun discovery for both of us to kind of like, this would really help. Again, that's the advantage of, some of the visualness of the video courses, like that you can kind of see this in action. So yeah, it's a nice course and got some really great feedback on it already.
Awesome.
So time for projects.
Yeah. Got a couple of cool projects today.
Yeah. When you pop this one in on PyCoders, I was like, oh man, this is for me again.
Yeah.
So everybody knows I'm really into sound and synthesizers and MIDI and that sort of stuff. And this is another dive into that. It's a 3-part series, basically calling Making a Synth with Python. It's on Medium. Mm-hmm. Actually, I don't remember it counting down my count, so I think it's one of the freer ones, which is nice.
Yeah, I think it's free. Yeah.
It starts off with really just the idea of an oscillator, and this is kind of goes into some of your love of math and working with creating sine waves, creating square waves, creating all these kind of waves. And then I really like the idea that, this is what you should be hearing. This is what it sounds like. He includes all these SoundCloud little links so you can kind of get an idea of what you're going to be creating with that. The name, the person who created this basically just says Alan. And it's Alan's Medium blog, which is kind of interesting. No last name given that I could find.
Yeah.
But after going into a pretty deep dive in oscillators, which you could run either in Python or in a Jupyter notebook, he moves on to what are called modulators, which is in synthesizers. There's a section, they're kind of broken into parts, where it's like, there's the raw oscillator, the waves themselves. And then modulators are basically determining things like, how fast the sound should start up, like an attack, how quickly it should decay, or should it hold the sound long, or should it have some kind of impact when you're holding the note down, or when you let go of the note, how quickly should it relieve. So it's this thing called an ADSR, the attack, decay, sustain, and release. So he kind of talks about that and creating those kinds of things, and then dives into controllers, which is how could you control this either via just like a pure program script, or actually getting into using MIDI with it. And he uses it looks like Pygame with it, which is very cool.
Yeah.
And again, all these things are in Jupyter notebooks, and again with SoundCloud clips to kind of play all of it off. So it's a really fun project if you're interested in either higher order math, or you're interested in kind of combining sound and Python together. It's a really fun project, really well presented. Kind of builds off some of the stuff that we talked about Jupilit. Again, kind of more specifically in this case, dealing with it in creating those individual sound waves and then combining them in interesting ways too. That's the part that gets me excited, is the whole idea of kind of creating new sounds by combining waves together.
Yeah, totally. It's so something that regular listeners don't know about me is that before, I think people at this point know that I like math.
Yeah.
But before I was really into math, I still am really into music. And I actually, in the early 2000s, played keyboards for a band out in Los Angeles, tried to do the whole rock star thing. But I got really into synthesizers, and I not inherited, my grandfather's still alive, but he had an old Korg DS8 FM synthesizer.
That's a fun one.
That he just gave to me. And man, I fell in love with it. And that was kind of my introduction to synthesizers. And I just used to spend hours just like playing with all the little settings and everything. So yeah, it is really fun to sort of, see how you combine these things to create really new and unique sounds. And the idea of doing it in Python is really, really cool and really intriguing. And I'd love to play around with it some more.
Yeah, I think this will be fun. I think it could lead into some of the other stuff you've been experimenting with and showing math in Python lately.
Yeah.
This week, I want to shine a spotlight on another real Python video course. This one we mentioned earlier in the episode. It's titled Navigating Namespaces and Scope in Python. It's based on a real Python article by John Sturtz. In the course, instructor Johan Vergier takes you through how Python organizes symbolic names and objects in namespaces. When does Python create a new namespace? How variable scope determines symbolic name visibility? And what is the LEGB rule? I think it's a worthy investment of your time to learn how namespaces are implemented in Python and how to navigate through the layers of scope in your Python applications. All the video courses on RealPython are broken into easily consumable sections and include transcripts, plus closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. So what do you got for a project?
Well, speaking of math, I've got a pretty mathematical project. It is from the Jet Propulsion Laboratory, NASA JPL. It's called F prime. It has nothing to do with derivatives for folks that are familiar with that notation. Or maybe it does. I don't know. But it's a software framework for rapid development and deployment of embedded systems and spaceflight applications. So this is like combining everything that I love in life. And it first popped up on my radar on Twitter from someone named Chris Anderson. And he just posted a picture of this Mars helicopter. So the new Mars rover, Perseverance, on board was carrying a little helicopter. And that is running an open source flight code that the NASA JPL team open sourced. So I went and checked it out and saw that 16% of the repository uses Python. I was like, wow, this is really cool. So the vast majority of it is C++. I started looking into it some more, and it just kind of kept getting cooler and cooler the more that I read about it. It's a really interesting project because, so not only does this mean that probably Python is running on the Mars helicopter, so we'll actually have Python running on Mars. I haven't been able to like 100% verify that, but all the indications are that is actually true. But it's really beyond that. I mean, this Mars helicopter is almost entirely open sourced, both software and hardware. So it is running Linux, which might be the first time we have Linux used on a Mars mission. And well, at least on a rover or something that's actually, physically on Mars. It is using this open source flight framework, which uses Python. And on top of that, all the parts that were used to build it are components that you can actually go buy off the shelf. So there's a possibility that you could recreate this yourself at home, which is really pretty cool. I mean, to think that kind of technology is going to be flying around on Mars, this little drone.
Yeah.
So I don't think it's actually flown yet. I don't think they've actually deployed it. So we don't know whether or not it's going to be successful. The Mars atmosphere is a lot thinner. There's a lot less gravity. So it's a very different environment to Earth. And I shouldn't say whether or not there's a lot less gravity. Actually, I don't know that for certain. I can't remember off the top of my head. But yeah, the Martian atmosphere is thin. In fact, looking at this article, it says it's got just 1% the density of Earth's atmosphere. So the mechanics of flight are pretty different.
Yeah.
I mean, it's probably a lot more difficult to generate lift on Mars than it is on Earth. But yeah, I just think it's amazing that we've got this little helicopter that hopefully will be successful and be able to fly. And it's got Python on it, and it's built using components that you can get off the shelf. And it just really seems like kind of a really unique and cool moment in spaceflight history that feels like, you don't have to have $1 billion to go build something like this. So
yeah, it's not outside the reach of the regular human. That's pretty cool.
Right. Yeah. It's really neat.
Well, awesome. Well, thanks for gathering all the articles and projects for us again this week, and I'll talk to you soon.
Yep, sounds good.
Don't forget, you can get started on DigitalOcean's app platform for free at do.co/realpython. I want to thank David Amos for coming on the show again, and I want to thank you for listening to the Real Python podcast. Make sure you subscribe to the podcast in your favorite player. And if you like the show, leave us a 5-star rating and a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.